All right. Today I would like to do a video about Erlang support in NFX, and I'm very excited about it because we have done a great job interfacing with Erlang, as you have probably watched our previous videos about it. But today we have finished the support for CRUD operations, that is like create, update, delete, that is like working with a database, the database that is hosted in Erlang. Well, for those of you who know what Erlang databases are, most of the time people use Mnesia as a real-time database integrated in Erlang solution. So what we try to do, we try to abstract the behaviors and the interface so we could work with Erlang data in real time without coupling our solution with Erlang, so to speak. So we could have the same level of transparency. So let's start by looking at the unit test. And so you know, NFX is an open source project. It is on GitHub, and you can get it at GitHub code NFX. There is a link in the video. It's right here, GitHub code NFX. You can also get a NuGet package or download the code from a zip file or fork it here, but whatever. So let's look at the unit test that we did here. So the whole point here is to abstract the behavior of Erlang in such a way that we could write .NET code that interfaces with the data store, and not think about Erlang specifics like PIDs, Erl references and nodes and all of that stuff. So, and we did it. And what we did is called ErlDataStore, and it implements NFX CRUD data store. So in this particular test, we do not use dependency injection, so I just allocate it right here. But of course, if you use NFX application container, then you just specify the type and it will inject it for you. But I set up my store, and then I set up some parameters that are for unit test. I hard-coded it for simplicity, but let's look at the test. So we have created a method called CRUD echo, okay? It just echoes something, and I specify the parameter. It's called message, and I use this word here that will round trip to Erlang, and it will come back, and now we execute the query as if it were a SQL data store or MongoDB or anything else. I just do an execution of the query. See, there is nothing here about Erlang. And I assert that row comes back, that the row has a echoed message field in it. And it says, you said Lenin, because I passed Lenin as a argument. Okay, and it also tells me the date time. It returns date time. Now let's look at another test case. So here I get a schema from my security definition table, which I happen to have a Mnesia in Erlang. Okay, but again, this could have been a table stored in Microsoft SQL or in Oracle. See, there is nothing here that talks about Erlang. So it is very well abstracted here. So now I create a dynamic row. Now, why do I create a dynamic row? Because I don't know what schema Erlang may have in its brains, so to speak, in its execution engine. And this stuff populates my schema. I create the row that has this schema, and then I put some fields in there, and I validate the row, see that there are no validation errors, and the validation definition is a part of the NFX CRUD schema. It's also available for Oracle, for Microsoft SQL, MySQL, Mongo, whatever, for anything you would want to use. And then we insert it in the store. We insert this piece of data. We insert it in Mnesia, in Erlang. Store, insert, row. And here you go. It returns you one row affected, okay? And then let's do a insert multiple. So here I just do again, I get my schema and I do in the loop, I do insert, and then I see that everything is affected. Then I query my security definition table. Now security, we just used it as a trading security, like people trade, like high frequency trading. That's what security means. It's like a symbol that they trade. This all comes from the legacy of some development that Serge Aleynikov did for Erlang, and we just love this topic because he's very well versed in trading and stuff. Okay, so basically we're inserting some exchange symbols here that come from Cleveland Exchange. Okay, and then they say exchange Cleveland, and this will fetch the data from the security definition table in Mnesia, in Erlang. We get a queried by exchange in Cleveland, and we are going to load it up, and then we're going to assert that the number of records is the same, and we're also going to dump it as JSON. See right here, we're going to dump it to console, to the unit tester. All right, so what else do we have here? So here we also do some tests with New York Stock Exchange. We do some upserts, inserts, and see, we change something here, and then again, load one row set, or rather, okay, where do we store? Okay, store, delete, delete by key, and all of that. Now, this is an interesting test. This test allows us to subscribe to world news. Now, this is very interesting because in NFX, we have added the definition for subscriptions. In the data access namespace, there is something called subscription store. The subscription store can be implemented by any data store that you want to use. So in Erlang, it's very organic to implement it because, as you know, Erlang has mailboxes and processes and nodes, and OTP, Open Telecommunication Platform, is the protocol that takes care of all of that stuff. So the CRUD subscription store allows you to subscribe, to create a named subscription based on the query. Again, this has nothing to do with SQL, guys. This is just a named value, bag of value key value pairs, okay? And then the mailbox that you get, the mailbox is basically like a buffer that you can buffer your data, or you can execute the reactive code with a callback on receipt, okay? Which is an event handler here, subscription receipt event handler, okay? So anyhow, this has nothing to do with Erlang. However, Erlang implements it. Erlang Data Store implements it. So let's look at the use case here. So I would like to subscribe to world news, and I would want to get 10 news, and I would want to get them every 250 milliseconds. And I just plop it in my query again. And then I open my mailbox, okay, and I say that I want to buffer stuff, and then I say that I want to do, I subscribe to the receipt, and then I do some magic here so my unit test doesn't freeze. I do an interlock increment on this stuff and see if I'm done, but basically this delegate is going to get called with the subscription mailbox and row change, which is the data vector that is going to tell you whether the row has been inserted, upserted, updated, or deleted in real-time database, for example, Mnesia in Erlang. Okay, so this way you can synchronize the row set here in .NET in your CLR process with Erlang automatically. So what I do here, I do store subscribe news feed, and I feed this query here, and I put this mailbox here. So now I can get the subscription data here, and I can get the buffered results, and I can dump them as JSON, just for, my purposes of viewing the result on the screen or something, in the unit test. Okay. And what I also can do, I can terminate the subscription by just disposing it, or I can dispose the mailbox, then it will dispose the subscription. If I dispose the subscription, it will gracefully close the Erlang mailbox. That's pretty much it. It's pretty neat. So how does it work? How does it work under the hood? How do we abstract this from Erlang, or Erlang from this? So now some crazy stuff here. .NET developers usually get pretty pretty frightened by this, scared, but people who know Erlang, they love it. Okay, so what we've done, we've created, okay, here, let's do this. We've created a batch file, okay, that basically starts the Erlang node called world, okay? World means like Erlang with window. You can download Erlang, it's free execution environment from whatever, just Google download Erlang, okay? And you get this great tool called Windows Erl host. So if I double click it, I get my host running. So here's my Erlang process environment where I have my command line, okay? And I can do a lot of stuff here, but basically my server is running because I have launched it in this what do you call it? In this directory where it has the files necessary to operate. So I may want to do NFX CRUD interface. I may want to compile this, okay, and then another one that I want to do is NFX test, okay, and I do get some beam files. So beam file is like a binary file that Erlang compiler creates, okay. So, but other than that, I should be source testing. Yeah, I'm wondering why this files got deleted, but anyhow. Oh, because I launched it from the wrong folder. I launched it from the GitHub folder. Anyhow, so you get this file. So this thing should now be, and now we need to do this. TFX schema. Okay, so I compiled all of the instruments that I needed, and I have my Erlang node running. And then what this would allow me to do is allow me to execute those tests. But you know what? Let me go to the I think I need to call this function quit. Okay, let me go to the proper folder here, because if I go to NFX source testing manual, not manual, it is a NUnit integration test, CRUD, Erl specific, and then I have all of the beams here. So I just run my my Windows Erlang host from here, okay, and everything is pre-compiled here already, which is cool. So now let's come here and see. So how do we create our queries here? Because this is just the name, right? So how do we resolve this to actual Erlang query? First of all, let's see if the unit test runs, and I'm just going to use plain old, what do you call it? Plain old. Let's try this. Let's try. Okay, let's try run all of them. Plain old NUnit runner, because it's like a separate process. So it is running right now against this node. So here is the Erlang server, and here is the JSON dump of the data that comes from Erlang. You see I have it in JSON, I have it in memory in .NET, so everything is cool. Now I'm going to subscribe. It's going to do the subscription test, and here is my world news. See, change type, absurd key, and the news, because I don't pass any key in this case, and I have my news 1, news 2, news 3, okay? So everything works. So how does it work? It works as this. As you know, in NFX, we have a full support for Erlang in terms of types. Okay, all Erlang types are brought to Common Language Runtime Paradigm, CLR. We have all of the internals worked out, like atom tables and nodes and monitors. For the monitor is something when monitor the connection on the OTP, the RPC server, the parsers, the mailbox registry, all of that stuff is implemented. Okay, so the project manager for this is Serge Aleynikov. He's one of the Erlang contributors on Erlang project and other projects connected to Erlang. Okay, and so pretty much all of this has been implemented by Serge. But this allows us to work with Erlang, but the problem with this approach is that if we wanted to use this in a .NET application, that would have coupled us with this library here, with the NFX library, NFX Erlang library, okay? So the next step that we took, we created the data access abstraction, purposely working with CRUD datasets in such a way that we're not coupled to Erlang, as those unit tests illustrate, but at the same time, we can utilize Erlang as a server. So let's look at this world news, or let's start from the beginning. What do we have here? We have CRUD echo. Okay, CRUD echo. So we find the query here that has basically this. And this is the standard Erlang function invocation syntax. This is module, which is an atom, function name, which is an atom, and this is a variable of type string, and it is called MSG, message. So basically, if we look at the test here, here is my variable, and I pass a string called Lenin, and I pass it to my Erlang node, okay? And the Erlang node returns me the schema in an XML format that I can, and it only does it once, okay? It doesn't return schema every time. It returns me the schema in the format where I have schema name, then every field is named, and there are a lot of parameters here, like whether the field is a key field, whether it is a required field, does it have any lookup values, like pick list or something like that. All of that is taken care off for you. So basically what happens then is that our parser parses this query script, okay, and it turns it into actual Erlang command, and it shoves this, pardon my French, down OTP pipeline, down the Erlang's throat, and Erlang implements it. So if we go, so this is for NFX test. Okay, so if we go to the Erlang source code, which is right here, so we open the NFX test module, and here we go. For those of you who are not familiar with Erlang, Erlang is a functional declarative, more or less, language where you would operate with functions and actors. Okay, it's not like Windows, or it's not like C or C++ or Java or C# where you have variables. Everything here is immutable, and what you get here is this: you get a function and you get a pattern match. And by the way, pattern matches are coming in C# 7, which makes me very excited about it, because C# kind of bridging the gap between kind of Erlang and pattern matching functional languages and CLR paradigm. So anyhow, so what we have here, we have a function, it takes a message, and when we say, when the message is list, that is because in Erlang, strings are pretty much lists of characters, which makes sense. And then what we do, we say now equals Erlang system time microseconds this, and then we return. Now you see in Erlang, this basically says this is a function body, and we return a tuple, tuple, different people pronounce it differently, a tuple of an atom. Okay, an atom, this is like a system identifier. It's called echo schema, and then you get a list of arguments where you concatenate usaid constant with the message that you originally passed as a functional parameter here, and then you dump now as the response. Okay, and then this thing gets mapped to this schema right here. Okay, so programming in Erlang would take those of you who are not familiar with the language some practice, but I'm sure that the audience here is more or less already accustomed to the language, how it does things. But what we have here, we have some stubs here for handling RPC and Let's look at the CRUD, for example, here. So here is the table. We create a table in Mnesia right here. Here's our definition. Now, this definition also comes from the script processor because we stipulate our tables or specify our tables as an XML file in this format, okay, where we have fields. It's very easy to work with, and transform it into Erlang record definitions, which is this file, I believe it's right here, header files, which is like a preprocessor feature of Erlang. But anyhow, so what we do here when the bonjour function is called, that is hello in French, this is when our node connects to Erlang. We create the schema, and we are ready to respond with the schema to the and this code is for unit tests, because this would on the server would generate automatically, of course. We wouldn't need to write this by hand every time. So this is generated from that XML file. But on .NET side, we know how to interpret all of this. So when you connect, you say bonjour, and you get the schema, and you get the types for various schemas that the Erlang server supports. And then you can pretty much do RPC. So how do you do RPC? You create your query, and you set your query build step or build action in .NET to embedded resource. It embeds into your DLL, and that gives you this very cool level of indirection, because this is a resource. And what if I wanted to use MySQL? Here you go. Then you just create a resource for MySQL, okay, and then you can do some write some query for MySQL. So basically, here is the point. Had this store been connected to MySQL, I would have executed the MySQL query. Had I been connected to MongoDB, I have it somewhere here. I have a okay, here, MonJSON right here. So here is the query for Mongo in the MongoDB format as a JSON with parameters. This is the syntax how you put parameters in here. Okay, right in the query, what do you call it? In query request. Okay, so that allowed us to create this level of indirection, which is so cool. So security definition. Here we go. Remember I showed you this, like, query all of the securities from Cleveland to our New York Stock Exchange. Here you go. NFX test, sec definition by exchange atom. Okay, which scopes this parameter to being an atom. Okay, and then here we go. We pass this atom, we synthesize it on the .NET side, and it gets converted to an atom and gets transferred as an atom to the Erlang OTP server. So Erlang can execute a pattern match. Where is it? NFX test. Somewhere here there is a function that does it. Subscribe, unsubscribe. World news. Okay, sec dev by exchange. Here you go. Here you go. You do Mnesia dirty select. I mean, it's not an elaborate query, but it's a basic query. And you can see this crazy syntax here for those of you who are not familiar how Mnesia does pattern matching with this tuple expansion syntax rather. But this is all on the Erlang side. You as a .NET developer, you don't care how it's done. It's done for you by an Erlang guru, okay? And then all you get back the secdef schema, and then you get back the result, which is a dirty select from Mnesia. That means that it doesn't go through the transaction, and the Mnesia is the database, like I said, which is integrated right in the Erlang core. So that's pretty much it. And for the subscription, here is my world news source that generates world news, and it does some stupid timer here just to emulate the delay that news come with some period with some interval, and the news come back here, and the Erl test, the Erlang Data Store would rectify all of the Erlang complexities for you, and it will just give you this callback with the data, and then you can examine it here in a form of a row. Okay, row, this is a NFX CRUD concept that is just a row of data, just like data table in .NET. Okay, so you don't need to know anything about Erlang. And that's pretty cool. I'm very excited about it, and I think we will add more unit tests and more test cases in general in future. But other than that, I think this is very useful for integrating existing software created on Erlang with the GUIs created in .NET, because in Erlang it kind of sucks, to be honest with you. Creating GUIs in Erlang, it's not an easy deal, but you can do it in .NET much easier, and you can interface with Erlang without polluting your code with Erlang specifics. The only place where you put Erlang specifics is here, when you query script handlers, okay? But that's the whole point. If you don't want to use Erlang, you can swap it. You can swap, it's like the dependency injection kind of thing, okay? Here, right here. So where I set up my data store, I could have injected here Oracle Data Store, and I could have injected, all of this comes from configuration script, of course. In this particular instance, I did it by hand, but like I said, you could have created it in the configuration file. And that's it. That's where it resolves the queries from. And some of the queries can be written in code in C#. If there is a special case where you couldn't write a complex query just by calling the functor on the Erlang side, then you would have inherited from the CRUD, Erlang CRUD query handler, and implemented the execute function, like I'm doing here for Mongo, for example. So for MongoDB, I am counting persons, okay? MongoDB does not have a server side, so to speak, what do you call it, count verb that you could invoke from the query syntax. So therefore, it's a system function, that is. You couldn't call it from here. There is no such verb as count. Server-side count, that is. You could do an aggregation framework call, but that's not good. So for that purpose, what we did here, we created a count persons, which is a MongoDB CRUD query handler base, and then what it does, it calls the special method collection count on our MongoDB driver, and it performs server-side. Let me underscore it. Underline it. Server-side count over this query, whereas the query is stated right here. You take your parameters in, and you bind all of that, and you do that, and you return a row that gives you back the count. That's what the rows are. Okay, you create a row. This is a type row which has count and interval, how long this query took to execute. I just surrounded it with a stopwatch. Okay. This is all for testing. What I'm saying here is that you create a queries in code. If your particular backend cannot execute this query at once, you could create them in code, okay, for those particular cases. You could do the same for Erlang. That's why I'm showing it to you right now. And other than that, that's pretty much it. And I hope you can, get some actual use cases in your scenarios, and I can answer you guys. Any questions, just email me, and we'll see how this works out. Okay, thank you for watching.